So week 10, which question?
8 practice assignment.
And let me try to open the question. Okay, so the question says the following. An LTI system is described using the following differential equation. Yeah, and now the question is to find the frequency response of the system. Correct? So even before trying to solve this, let's try to recall some basics from what we have learned regarding the LTI systems. Yeah. So what did we learn regarding an LTI system? So if x of t is the input to an LTI system, its output is y of t, and the system is defined by its impulse response h of t, and y of t is nothing but the convolution of x of t with the impulse response of the system h of t. When you write in the frequency domain representation, y of j omega is nothing but x of j omega times h of j omega. Correct? Where y of j omega is the Fourier transform of y of t, and x of j omega is the Fourier transform of x of t, and h of j omega is the Fourier transform of h of t. Right? So this is something that we know from the Fourier transformation and the LTI systems. Now let's try to understand the question. So the LTI system is defined by this differential equation, and you're supposed to find the frequency response of the system. So the LTI system, the given LTI system, as we know, is LTI system is defined by the impulse response h of t, and the frequency response of the LTI system is given by h of j omega. The question is asking you to find from this input output relationship, you're supposed to find the frequency response of the given LTI system, that is h of j omega. So now how do we find that? So we have the input output relationship, and we know that for an LTI system, y of j omega is given by x of j omega and h of j omega, which implies the frequency response of an LTI system is y of j omega by x of j omega. So now what we have to find is, from this differential equation, we are supposed to find this fraction. How do we do that? So we know that if x of t has Fourier series representation x of j omega, what is d by dt of x of t? Can you tell me?
Then j omega x j omega.
J omega x of j omega. Suppose d square by dt square x of t, then what it would be? So how can you write this? You can write this as d by dt of d by dt x of t, right? If you call this as y of t, right? Or if you call this as x prime of t, this will have Fourier series representation x prime of j omega. Now, what is x prime of j omega? It is the Fourier series representation of x prime of t. What is x prime of t? That is x of j omega times j omega, right? So this would be your sorry. So yeah, this is j omega times x prime of j omega, where x prime of j omega is j omega times x of j omega. So for this, the Fourier series representation is j omega whole square x of j omega. Correct? Yeah.
Yes, ma'am.
Now what you have to do is, so this is the input output relationship that is given. Let me try to write the given input output relationship. So d square pi of t by dt square plus 5 times dy of t by dt plus 6 times y of t is 4 dx of t by dt. So now when you take the Fourier series representation, what happens to this? This is j omega. Uh, Recall that if x1 of t has Fourier series representation x1 of j omega, x2 of t has Fourier series representation x2 of j omega. Fourier transform, sorry, it's not Fourier series representation, this is Fourier transform, I'm really sorry. So Fourier transform is linear, so the Fourier transform of x1 of t plus x2 of t is x1 of j omega plus x2 of j omega, correct? So using this property, linearity property, also um, it's linear in the sense a times x1 of t, b times x2 of t has the Fourier transform a times x1 of j omega, b times x2 of j omega. So this is known as the linearity property of Fourier transform, right? So using this linearity property, the Fourier transform of this entire expression would become j omega whole square y of j omega plus j omega times 5 y of j omega plus 6 y of j omega, which is equal to 4 times x of j omega. right? So from this, what you could see is y of j omega times minus omega square plus j omega times 5 plus 6 is nothing but 4 times x of j omega, correct? From which you could see that y of j omega divided by x of j omega is nothing but 4 divided by minus omega square plus 5j omega plus 6. As we have seen earlier, this is nothing but h of j omega, that is the frequency response of the system, is nothing but 4 divided by 6 minus omega square plus 5j omega. Is that okay?
Yes, ma'am.
So this is how you are supposed to solve it. Let me just try to repeat it again. So there are two concepts involved in this. So you have to be comfortable with the two concepts. There's nothing to do with the ODE here. You don't need to scare about the ODE that was given. The key concepts in this problem are in an LTI system, the output is nothing but input convolved with the impulse response of the system. When you try to write them in the Fourier transform frequency representation, that is the Fourier transform representation, from the properties of Fourier transform, what happens to the output in frequency domain? Now it's the multiplication of the input in frequency domain times the uh, impulse response in frequency domain. So this is one of the key concepts that we use, right? So from this property of the Fourier transform, what we have is the frequency response of the system or the impulse response in the frequency domain, which we denote by h of j omega, is nothing but y of j omega divided by x of j omega, where y of j omega is the Fourier transform of the output y of t, x of j omega is the Fourier transform of the input x of t, and h of j omega is the Fourier transform of the impulse response h of t. Now, from the given system relationship, we have to find this response. So how do we find? Now we use, so we know certain things. So if x of t has the Fourier transform representation x of j omega, then differentiating the input signal will add some factor of j omega in front of the frequency representation of the input signal in the frequency domain, right? So as we keep doing this, like we know what happens to the input in the frequency domain, and we also know that Fourier transform is linear, and because of that reason, from the given input output ordinary differential equation, we try to write it in terms of the Fourier transform representations, because this is simpler to solve, and then we try to analyze the uh, uh, the fraction, which is nothing but the frequency response of the given system. And yeah, as we were discussing, like in our earlier week lectures, that Fourier transforms helps us in solving the differential equations. So how does it actually help us in solving the differential equation? If Fourier transform is not there, you know from this input output relationship, where y of t is x of t convoluted with h of t, it is nearly, like, it is very difficult to find what happens to the impulse response h of t from this relationship. But when you have the Fourier transform representation, things become much simpler. Now you know the frequency response of the system, and you have to just use the inverse Fourier transform on this IFT of h of j omega, would simply give you h of t, which literally made your life easier. Does that answer your question?
Yes, ma'am.
Yeah. Any such doubts? More doubts? Yeah.
Question 9 of practice assignment 10. First, we have to find h of j omega, then find
H of
inverse
t.
of this.
Yes, correct. That's true. Otherwise, it's very hard to find. So you found h of j omega from your previous question. From this h of j omega, now you go back and try to find the Fourier. Sorry, you go back and find the impulse response by using the IFT. How do we do that? So this can be written. I think I missed one term here. So this should be j omega because d by dt of x of t. So there is a factor of j omega, 4j omega, j omega. How can you do this? So this 4j omega divided by omega square plus 5j omega can be broken into two parts, factorization. So this can be written as 12 by j omega plus 3 minus 8 by j omega plus 2. And yeah, we know that, yeah, we know that the Fourier transform of, what is Fourier transform of u of t? What is Fourier transform of u of t? Right? Uh, are you with me? Am I audible?
Yes, ma'am.
Yeah, what is the Fourier transform of u of t? You should be comfortable enough with these things, right?
Yes, ma'am.
Did let me also open your lecture notes so I'll get to know like what are available in your lecture notes. I'm not able to open. So is the lecture notes uploaded on the portal? I requested the team to upload it in the portal.
No, ma'am, not yet.
Oh my god, I have been telling them multiple times.
Been waiting since week 9.
Yeah, I know, like, yeah, even we are telling them,
Ma'am, if possible, share the link here.
oh, like that, maybe I'll do that. Hold on.
Yeah.
So let me do the following. Can you share it with your friends? This link?
Yeah, I will share.
Sure. Yeah, I shared the link here. This contains the MATLAB code and the lecture notes. Okay.
Thank you, ma'am.
Yeah. Yeah, did you guys find like what is the Fourier transform of the step function? I think in your last lecture, sir was explaining you, right? Step function is a discontinuous function, so it's not very straightforward to find the Fourier transform of the step function, but you can express it in terms of the impulse responses and then you can find the Fourier transform, right? I think he was explaining it to you, I think, Satyam, correct?
Yes, miss.
So what is the Fourier transform of the step function?
Um, uh, Pi delta omega plus 1 by j omega.
Yeah. So this is the Fourier transform of the step function. And I think there are also other things. What is Fourier transform of e power minus t u of t? Or
1 by
Fourier transform of e power minus at u of t. What happens to this? This is 1 by j omega plus a, correct? I mean, when you face the difficulty, instead of remembering the transforms, it's always better to calculate. How do we calculate the Fourier transform? Correct? Are you guys with me?
yes, ma'am.
So this is correct, right? Yeah. So when you solve
Yes,
this,
ma'am.
like what would you get? 1 by j omega plus a, right? So now what you have to find is, so what we know is Fourier transform of e power minus at u of t is given by 1 by j omega plus a. What you have is IFT of 1 by j omega plus 3. What would this be? E power minus 3t u of t, correct? Yeah. So when you take IFT of this whole thing, try to break it down into two parts. Again, inverse Fourier transform is linear. So this is just 12 times IFT of this whole thing minus 8 times IFT of 1 by j omega plus 2, because inverse Fourier transform is linear. And when you try to do this, from what we know, what we get is simply 12 e power minus 3t u of t minus 8 e power minus 2t u of t. Correct? That is all it is. Yeah.
Yes, ma'am.
So, yeah. Yeah, it's always so when you have the differential equation and when you're asked to find the impulse response in time domain, it implies you have to find the things in the Fourier transform domain and then try to find it in terms of the time domain representation. Okay, that is what it means. Is that okay?
Yes, ma'am.
Any more questions? Yeah, any of the questions?
Ma'am,
Yes.
question 6.
Question
Week
6.
10 practical assignment.
Week 10, question 6. Just a second. I got an email from. Oops. Question 6, right? What is question 6? Week 10, question 6. Okay. Finding the Fourier transform, right? You tell me like what is the problem that you're facing so that I'll try to help you with, like, if you have any concept difficulty, I'll try to help you with that. You're supposed to find the Fourier transform for the following signal, which is defined as x of t is 1 minus t 1 plus t Yeah, could you tell me like what is the difficulty that you're facing with this problem? Let's try to solve this together.
Ma'am, I'm facing difficulty in finding Fourier transform.
Uh,
To solve
uh,
it.
what exactly is the difficulty that you're trying to see? So let's solve this step by step, okay? So how do we find the Fourier transform of any given signal? So there are multiple ways. The basic method is to, what is a Fourier transform? Suppose x of t is the time domain signal. It has another frequency domain representation, like as we were discussing last time. The signal, like it looks in some way on Earth. Maybe it has a different form on the moon. So this is what we are calling when we say, there is some space time and the signal is in some way in the time axis. There's another space frequency and the same signal looks in a different way in the frequency, and these two representations are equivalent. I mean, if a signal looks like this in the time axis, it looks exactly like this on the frequency axis, and if the signal is like that in the frequency axis, then it looks like this in the time axis. So that is what we mean by this Fourier transform equivalence, right? And how do we go from the time axis to the frequency axis? Fourier gave us this nice analytical formula to calculate how it exactly looks like in the frequency axis. And what is the formula? So x of j omega is nothing but integral minus infinity to infinity x of t e power minus j omega t dt. Correct? Are you with me?
Yes, ma'am. Yes,
Now,
ma'am.
now the question is to find for this kind of signal x of t, if x of t is some signal like this, let's try to plot this signal. What is the signal? So it is 1 minus t from 0 to 1, and it is 1 plus t from minus 1 to 0. In all other places, it is 0. So this is the given signal x of t. So x of t looks like this triangle in the time axis. Now the question is to find how does this x of t look like in the frequency axis, which we call x of j omega. What is the representation of the signal in the frequency axis? This is what we are supposed to find. At least the question is clear. And we know how do we go from the time domain to the frequency domain. We have this nice analytical formula to calculate the Fourier transform, which was given by Fourier. And let's try to evaluate it. So from minus infinity to minus 1, x of t is 0, e power minus j omega t dt, plus from minus 1 to 0, it is 1 plus t, e power minus j omega t dt, plus from 0 to 1, 1 minus t e power minus j omega t dt, plus integral 1 to infinity 0. And then you need to solve this. When you solve this, like what do you get? What you get is from 0 to 1, it is 1 minus t e power minus j omega t plus so this is minus 1 to 0, 1 plus t e power minus j omega t dt. Let me do change of variables. Let t prime is minus t. Okay. Then dt prime is minus dt. Correct. And when t when t goes from minus 1 to 0, minus t goes from 0 to 1, or minus t goes from 1 to 0. So how does this look like? So this can also be written as integral 0 to 1, 1 minus t prime e power j omega t prime dt prime. How did we get this? Change of variables. Okay. So this is same as 2 times integral 0 to 1, 1 minus t e power minus j omega t plus e power j omega t dt, which is nothing but 2 cos omega t. So this is integral 0 to 1, 1 minus t, 2 cos omega t dt. And you solve for this, what you would get is there any mistake with the solution that was given? Yeah, nothing. So when you solve for this, like what you get is 4 sine square omega by 2 divided by omega square. Just solve this integration. And this can also be written as, we know that, sin square of omega divided by 2 pi. Is that okay?
Yes, ma'am.
So yeah, you need to understand and you need to practice more and more problems when it comes to these kind of problems. So this is a simple enough problem to solve using the direct definition of the Fourier transform. But there will be some tricky problems where the direct application of the definition of Fourier transform may not help you. But in such cases, you may have to use the properties of Fourier transform. For example, when you have this differential equation expression, it's not you can solve it, but it's always simple to just use certain properties, known properties of the Fourier transform, to come up with the solution in a simple way. Okay, so when to use the direct definition, when to use the property, it comes with practice. You need to practice more and more problems, think about it, like what is the easiest possible way that you can arrive at the solution. And yeah, as per this problem, like what it states is, if the time domain representation of any signal is a triangle signal, then its frequency domain representation is a sinc function. Okay, so that is what this means. This problem is all about. Is that okay?
Yes, ma'am.
Yeah. Any other questions? Any other questions? Forgot to mention, your NSEM end term will be containing questions mostly from Laplace transform and the Fourier transform. Okay, you'll also have some questions from quiz 1, quiz 2 topics, but mostly it will be on Laplace and Fourier transform. Okay, Fourier transform, Fourier series. At least 70% of your NSEM carries weightage on these topics. Okay. Any other questions? Difficulty with conceptual understanding? Any questions? If you have any questions, please stay. Otherwise, we can end the session. I mean, yeah, if you're having any difficulties, we can discuss regarding those topics. How is it going? Like other courses, everything is going well. So,
Yes, ma'am.
One small,
mm,
just a general doubt.
mm, mm.
Just a general doubt.
Yes, yes.
Ma'am, if we are not in a position like unable to get the intuitions of the concepts, I mean, will it be a problem, or is it something like, okay, time wise you will be getting the intuitions?
Uh, so, which kind of topics are you facing difficulty with respect to the intuition?
Will you stop the recording, or shall I continue? No worries.
Maybe then you can hold on. We can discuss
Yeah,
at the
yeah,
end of the
yeah,
session.
yeah, no worries. Yeah, I'll do it.
So we can discuss if you have any technical questions. Otherwise, I can end the recording and we can talk on if you have any specific doubts. So,
Ma'am, could you explain Fourier transform of periodic signal?
Fourier transform, yeah, we can do that. So, what is the difficulty that you are experiencing with? So, let me put it straight. Uh, any periodic signal, let me also open the class notes that so that I'm consistent with the notation. Somewhere sir was discussing about the Nyquist sampling and all, right? Yeah, all right. So this is the idea. Any periodic signal x of t can also be written as x of t convoluted with sum over n from minus infinity to infinity del of t minus nt. Okay, where t is the fundamental period. Is this okay? Do you agree with this, or do you have any difficulty agreeing with this?
No,
So this is
great.
okay. Okay. Now, how do you find the Fourier transform? So convolution, what does it make? Uh, you know, uh, what does it do to the Fourier transformation? It, so let me call this thing as some z of t. Okay. So x of j omega is x of j omega times z of j omega, right? Because convolution in the frequency domain representation, it becomes multiplication, right? And when you have your z of t as summation n from minus infinity to infinity, what happens to z of j omega? Basically, this can be represented as del of t plus del of t minus t plus del of t minus 2t plus and so on plus del of t plus t plus del of t plus 2t plus and so on. And again, Fourier transform is linear, so this would be Fourier transform of del of t plus Fourier transform of del of t minus t plus and so on plus Fourier transform del of t plus t plus and so on. Think what happens to this Fourier transform. It is nicely solved in your lecture notes, lecture number slide 201, and this turns out to be 2 pi by t sum over n from minus infinity to infinity del of omega minus n 2 pi by t. This is what that happens with the Fourier transform for this sum, and hence any periodic signal x of t, it can be represented as x of t convoluted with sum over n minus, and its Fourier transform is given by x of j omega 2 pi by t. Is that okay?
Yes, ma'am.
Yeah, if you have any, I mean, if you want to see the proof of this, please look through your lecture video at slide 201. I think it's nicely derived, and you also have, you know, something known as the sampling frequency, and he'll also be talking about what is known as the Nyquist sampling and all. You know, it's good to understand that, but this is how you find the Fourier transform for any periodic signal. So for any periodic signal, the Fourier transform is this. And what is x of j omega? This is the transform of the signal within one fundamental period. So x of t defined in one fundamental period. Suppose if you have some signal x of t like this, okay? So this is a periodic signal, minus 1, 1, maybe let's call 2, 4, and so on. So if this is the given signal, how do you find the Fourier transform? You find the transformation of the signal within one fundamental period. So here in this case, find the transformation for the signal from here to here within one fundamental period. Find the transformation of this signal, okay? So that we represent by x of j omega, and we multiply that transformation with, this. Where t here in this case, t is simply 2. Is that okay? For any periodic signal, this is how you find the Fourier transform. Find the Fourier transform within one fundamental period, which we denote by x of j omega, and multiply that with this factor. So this is constant for all periodic signals. T is the fundamental period. That is the only thing that varies. Is that okay?
Yes, ma'am.
Any further questions?
Ma'am, in practice assignment question 3,
Which
just
practice assignment?
till 10, question 3. Ma'am, just tell the approach how to proceed in this question.
Why you are always having difficulty with representing sine and cosine signals in the exponential forms? I think that is why you're facing difficulty in solving these questions. But but you know, they are the simplest questions. Even while doing Fourier series thing, you are having difficulty with this sine and cosine kind of problems. Always remember that sine omega t can be written as e power j omega t minus e power minus j omega t by 2j, and cos omega t can be written as e power j omega t plus e power minus j omega t divided by 2. Ground rules, always remember them, okay? And when you see these kind of problems, you should be happy to look at them because they are pretty much simple. So what it says is you're supposed to find the Fourier transform of sine 2 pi t e power minus t u of t. Okay, we know two ground rules. One is sine 2 pi t can be represented in this form, and the other thing that we know is Fourier transform of e power minus at u of t is nothing but 1 by j omega plus a. Simple. From here onwards, things are simple. We know these two ground rules, apply them. So, what is this? So, this is simply Fourier transform of e power j 2 pi t plus e power minus j 2 pi t, sorry, divided by 2j, yeah, times e power minus t u of t. Fourier transform is linear, hence we have this as Fourier transform of e power j 2 pi minus 1 times t u of t minus 1 by 2j Fourier transform of e power minus j 2 pi minus 1 times t u of t. From here onwards, you know, right, how to find. Yeah, are you there?
Yes, ma'am.
So, simple two ground rules. Rule number one, rule number two, apply them. That is all is there in this problem. Nothing more than that. So always please remember this. I'm seeing you. So yeah, you are having some difficulty with this representation. When you come when it comes to solving Fourier series or Fourier transform, you always work with the exponential signals, and integration of the exponential signals is the best thing that can be done. And when you see something in the form of sine and cosine, always convert them into exponentials and try to work from there. Okay,
Okay.
yeah, any other questions?
No, ma'am.
The topics are pretty much simple, but you need to practice a lot. Fourier series, properties. Fourier series is given only for periodic signals. And when it comes for the aperiodic signals, we have Fourier transform, properties, Laplace transform, properties, pole zero plots, region of convergence. You know, all these things you should be very familiar with when it comes to the enzyme. So practice as much as possible. I'll see if I can extend the week 11 assignment deadline to maybe Friday. Okay, I'll request the team if I can make the week 11 assignment deadline as Friday, end of Friday. Okay, so I'll check with the team. And I also shared the link to the lecture notes and the MATLAB code. Please share it with your friends. Okay, I think that is all for today's session. If you don't have any other doubts, can I end the recording?
Yes, ma'am.
Ma'am, week 11 deadline is